In this recording, we're going to learn about sinusoidal modeling. Sounds pretty complicated, but it turns out there's a lot of real-world phenomena that can be modeled by periodic functions, like sine and cosine waves like we see here. So anything that has like a tide problem or a phases of the moon or something that is cyclical like that, periodic, we can try to model it using a sine or cosine function. We really just need to figure out what the A, B, and C are going to be in order to make it a good fit. So let's review a little bit about what we know. Amplitude is the A value. It's always positive. Okay, so it's the absolute value of whatever that A is, and it's the amount that it rises and falls above that midline. Midline, okay, so if I have a sine wave, the midline would be right here, and the amplitude is this amount that it goes above and below that. The maximum goes above and the minimum goes below that midline. Then the period, well, I skipped frequency, but the period is the minimum distance for it to repeat. Okay, and the frequency is how many cycles we have within a 2 pi interval. So again, B times P, the frequency times the period, is always equal to 2 pi. So let's look at this particular situation. We have a tide that has particular data given to us, a couple data points, and we're going to model it with this cosine wave. We're going to graph it here, and then we're going to figure out what the A, B, and C are to create a sinusoidal model. So I'm going to ask you to read everything in this paragraph, all the given information, and then try to set up your axes appropriately to represent the given data. And then if you can plot a few points, even better. Play the recording when you're stuck or you want to check your answer. Okay, so hopefully you took time to set up your axes and plot the points you know. I'll do that very quickly. Okay, so I've got these axes set up. I know the tide has a period of 12 hours. You get high tide every 12 hours. And it asks us to draw 2 full periods. So I know I'm going to need it to get out to 24 hours. So that's why I've done that. I've tried to space these evenly. I also know that the maximum depth of the water is 36 feet and a minimum of 22. So I want to make sure I get all the way up to 36. All right, now in terms of starting to plot some points and figure out how this graph is going to be displayed here, we've got to use these values, the max of 36 and the min of 22. Well, I know the midline is right in the middle. It's the average of those. So let's go ahead and quick find that average. And of course, that is the C value. So 29. Okay, now that I've established the midline, I know I can go above and below that midline the same amount. So it would be 7 above the midline to get to 36 and 7 below the midline to get to 22. So that all kind of squares out. Let's plot some points. So because it's a cosine, I know normal cosine looks like this, right? It starts up at a maximum, goes down, and completes one cycle, gets back to its maximum. So I want to plot a point at 36 to start. And then I know after 12, it's going to be back to 36. Okay? And then I know at the halfway point, at 6 hours, it's at a minimum, so it's at 22. And therefore, at 3 and at 9 hours, it's got to be on the midline, because everything is split up into quarters. Okay, so hopefully that looks reasonable to you. Then we're just going to continue that cycle. Nice. Now I need to come over here and determine the values of A. Well, A is simply going to be the difference between 36 and 22 divided by 2. So basically half the difference between them, right? It's that a little amount there, which is 7. And then B, well, we know that P times B equals 2 pi always. And we happen to know how long it takes for the cycle to complete, or the graph to complete one full cycle, which is 12 hours. So we know 12 times B equals 2 pi. When I divide both sides by 12, we get pi over 6. Okay, and we could graph this on our calculator to verify this works out. Let's do that. So if you have a graphing calculator, hop over here. We're going to do a cosine graph that has an A value of 7. Okay, so it has my value of A and B and of C. I'm going to make sure I'm in the right mode, which I am. I'm in radian mode. Then I want to set up my window to match what was on my paper. So in the X direction, okay, so 0 to 24 in the X, 0 to 40 in the Y. Just hit graph. There's that nice graph. The final part about this question involves a context with a tanker boat. So why don't you read this paragraph and then see if you can set up the inequality, which we'll then solve together on the calculator. Okay, so as it says here, tanker boats cannot go in water that is less than or equal to. In other words, they must have water that is greater than 25 feet. So we're going to set up something here with that same equation we just entered. 7 times the cosine okay. And we're just going to put that into our calculator. We're going to use so we're looking at this line right here. That goes at 25 right here. So anything below there is no good for the tanker. And I need to find out what are the values of these points. We're going to use the graphing calculator to do that for us. So over here, let's pop into here. Let's put in Y2, 25. And let's look at a graph. There's our graph. I need to find these points right here. 1, 2, 3, 4. And we can do that using second calc intersect. It's going to ask us some questions. It's going to say first curve. Is that our first curve? Yes, it is. Second curve. Is that our second curve? Yes, it is. But there happen to be 4 points. It doesn't know which one we're speaking about. So it's asking us to guess. So you just need to cursor over and get somewhat close to the place that you're interested in guessing first. Hit enter. And so it said to round to the 10th, so we're going to call that 4.2. Okay, continue that process. This time specifying a guess location that is a little closer to here. So one more time. Second, calc, intersect, first curve, enter, second curve, enter, guess, just move it over and be somewhat here. So 7.8. Again, I'm going to keep track of these places here. And I think I confused myself before. I'm going to change this. Actually, I want this to be the opposite symbol. I'm going to change it around to be that these are the times when the water level is less than or equal to 25, because that's what it says here. When the tanker cannot be in the bay, I was finding out when the tanker can be in the bay. So we have to make sure we're answering our question. So we're actually going to be between 4.2 and 7.8. The tanker cannot be in the bay because it's going to be equal to or less than. Those are these points right in here. Equal to or less than the 25 foot mark, and I also need these 2 points right over here. Well, I'm going to go through the second calc intersect process one more time, but after I do that, I want you to have a little moment of, oh, and see if maybe we could have gotten these numbers, these values over here, without even the calculator. So let's check this out. So one more time, I'm just going to go through this fast. Hopefully you'll do it on your own. Find those two values. So 16.2 and 19.8. Take a moment to reflect on the relationship between those numbers. Play the recording when you're ready. Okay, so hopefully you recognize, hey, I just added 12 to each of those because the graph repeats every 12 hours and it just shifts over 12. Not a coincidence. Okay, for exercise 2, there is no graph to make. I would like you to just do all the calculations you can and then play the recording when you're ready. Okay, so hopefully you've got enough background to be able to take this question on. It wants to know the max and the min. And so we've got our midline. And so our max is going to be found by taking our midline plus the A value, the amplitude. And our min, subtracting, going down below the midline. And then how much time does it take to return to the maximum height for the first time? Well, that has to do with the period, right? Wants to know the period. So think about the relationship you know and try to figure out the period. Okay, hopefully you said P times B is equal to 2 pi. We don't know P, but we do know B is pi. It's always the coefficient of the X, or the T in this case. So, and of course, the only number that makes sense here would be 2, right? So the period is 2, and the question is 2 what? Well, we have to go back to find the units. Turns out we're measuring this in seconds. It's going to take 2 seconds for this to occur. Okay, last question. I want you to read through this question, find out the A, B, and C, and make that graph. Or possibly make the graph and then find out the A, B, and C. Play the recording to check your answers. Okay, so I'm hoping you did all that work. I'm just going to work out this quickly. So now that I've found the values of the midline, and I know the period is 8 minutes, and I know that it has an amplitude of 62.5, I can just draw in my midline and then plot the rest of the points. So you may have noticed I went back and put an absolute value around this A, because I don't know right away if the value of A is positive or negative, but just modeling this situation, it makes sense that the person starts out at the bottom, right? Starts out at a height of 5, not way up in the air, and they get back to 5. So it's a negative cosine graph, okay? And again, it's always broken up into fourths. If you start at a minimum, you get back to a minimum. Max is in the middle, and you hit the midline in between the mid and the max. Thanks for watching.